Hello and welcome to GS Podium. In this presentation, we'll discuss the formal definition of data structures, advantages of it, and the types of data structures. So let's get started. What is data structure? A data structure is the organization of the data in a way so that it can be used efficiently. So efficiently word here means in terms of time and space. In other words, it can be used to implement an ADT. This we got to know from the previous presentation where we have seen an example that to implement a stack ADT, we need to use an array data structure or linked list data structure. So, data structure is used to implement an ADT. ADT only tells us what is to be done and data structures tells us how to do it. Up to now, we have got to know that ADT gives the blueprint and data structures gives us the implementation. But how to know which data structure to use for a particular ADT is a question of concern. We know that there are multiple data structures which can be used for a particular ADT, but which data structure to follow and which not to follow is a question of concern. Let's tackle this problem. Which data structure? In reality, different implementations of ADT are compared for time and space efficiency. For example, if we talk about stack ADT, it can be implemented using arrays as well as linked list. One of the data structure maybe saves space and another maybe saves time, but both the data structures will be compared for time and space efficiency, and the one best suited for the current requirement of the user will be selected. If the user wants to save space, so the data structure which is fulfilling the best current requirement will be selected. And if the user wants to save time and if the user wants the program to run faster, so the data structure which runs appropriately will be selected. Now let's discuss the advantages of the data structures. First one is efficiency. Proper choice of data structure make program efficient in terms of time and space. So that means the proper choice of the data structure is very important because the user will be talking in terms of time and space. So the data structure which is best suited will be chosen. Next is reusability. One implementation can be used by multiple client programs, so it offers us reusability. And the third one is abstraction. This we already got to know from that data structure is specified by an ADT which provides a level of abstraction. ADT is just a blueprint and is just a interface. Client program does not have to worry about the implementation details. It is only connected with the ADT. Now let's discuss the types of data structures. So data structures are of two types, primitive data structures and non-primitive data structures. Primitive data structures include integer, float, character, boolean, and non-primitive data structures include linear data structures and non-linear data structures. Further, linear structures include arrays, linked list, stack, and queue, and non-linear data structure include tree and graph. Now let's discuss non-primitive data structures. Firstly, we'll discuss linear data structures. So data structure is linear when all the elements are arranged in a linear sequential order. For example, arrays, linked list, stack, and queue. So all of these are linear data structures because their elements are arranged in a linear sequential order. Another way we can explain that a data structure is a linear data structure if each element has one predecessor and one successor, except for the element at the first position and the element at the last position. First element does not have a predecessor and last element does not have a successor. So this is an exception, but this showcase that all the elements or all these types or all these examples are linear data structures. Now let's discuss nonlinear data structures. A data structure is a nonlinear data structure when all the elements are not arranged in a linear or sequential order. There is no linear arrangement of the elements. Here we can see two examples. One is tree data structure and another is graph data structure. So in both the data structures, each node have one predecessor but do not have one successor. Rather, it have two successors. So the arrangement is not in a linear or a sequential manner. Once we have understood linear and nonlinear data structures, let's go even further and discuss static data structures and dynamic data structures one by one. Now first discuss static data structures. In these type of data structures, memory is allocated at the compile time. Compile time means at the time we are creating the code. So at that time the maximum size is fixed. For example, here the array is fixed with the length 9. So the advantage is that whenever we want to access the element from this array, it is or it can be accessed very fast. Disadvantage is that the insertion and the deletion process goes very slower. This we'll discuss later on. Now let's discuss dynamic data structures. In these type of data structures, the memory is allocated at the runtime. So therefore, the maximum size is flexible. So because the user will decide the length of the program or the length of the code, so here the insertion and the deletion is an advantage and slower access is the disadvantage. For example, if we talk about the linked list, so this is a dynamic data structure and we can see that advantage of one is disadvantage of another. So we cannot say that which one is better. It is purely dependent on the user requirements. That's all for today's lecture. Thank you. Please like, share, comment and subscribe to my YouTube channel which is GS Podium.